Is my screen visible?
Yes, sir.
Yes.
Yes, sir.
Yes, sir.
What you can see? What you can see on screen?
Preparation and standardization of X molar sulfuric acid.
Yes. Okay. So in today's practical, we'll discuss out preparation and standardization of X molar sulfuric acid, right? So the first part is the preparation. So in this we'll prepare 0.05 molar sulfuric acid. The final volume is 100 ml. That will act as secondary standard. Means કે એવું solution કે જેનું concentration strength exactly આપણને ખબર ના હોય. Just like H2S NaOH, અહીંયા બી એની property છે H2SO4 ની કે એ moisture ને gather કરી શકે. That is why you won't get the exact strength. Okay, so what will be the first step in the preparation of 0.05 molar H2SO4 solution?
Sir, we find the mass of the sulfuric acid to be added in 100 ml using the formula of molarity.
Okay, so for that you should know the molecular masses, right?
Yes, sir.
So any time when you have been asked to prepare molar solution or normal solution, you supposed to know its molecular weight or molar masses. So whatever molar masses, so for H2SO4 it is 98 gram. So when you dissolve 98 gram in 1000 ml, that solution is 1 molar. But we need to prepare 0.005 molar 100 ml solution. So what will be the next step? Yes?
We will find for 100 ml.
100 ml.
Okay, but the problem is, here the problem is molecular weight is given, that is in 98 gram, but you might have seen H2SO4. જોયું છે બધાએ?
Yes, sir.
Okay,
Yes.
in
In
which
liquid.
state it is available in
Liquid.
liquid state. So how we are going to weigh that liquid?
Sir, using the formula of density.
Yes,
Then
we need to convert our grams into its volume because we have to measure the volume of H2SO4. We need not to weigh. It is very difficult to weigh H2SO4. We have to measure its volume. So for that we are supposed to know its density, and for H2SO4 it is 1.8 gram per ml. Okay, so कैसे कोई मैंने कितना कन्वर्ट करशो आने 98 ग्राम ने वॉल्यूम में considering this density?
Density equals to mass upon volume.
Yes, then
So volume equals to mass upon density.
volume is equal to
Mass upon density.
mass upon density.
So 98 upon
बराबर
1.
છે?
Sorry, sir.
No, I am asking to other people.
Yes, sir.
બરાબર છે?
Yes, sir.
Yes, sir.
So when you convert by this formula, you will get 54.44 ml of H2SO4. You can double cross check it. Whatever mass you have, that you have to divide it by its density, so you'll get the volume, so which is 54.44 ml. So now for H2SO4, when you measure that this much ml and dissolve it in 100 ml total volume, then you will get 1 molar H2SO4. Now what will be the next step? It is given for 1 molar. We need to convert it 0.05 molar. Okay, so for 0.05 molar, how will you convert it?
By the formula of molarity.
Cross multiply.
Yes, that is the only way. You need to cross multiply it. 1 molar માટે 54.44 છે. 0.05 molar માટે કેટલા? That's it. Okay, so multiply it with 0.05 molar and divide by 1. So 54.44 into 0.05 divided by 1. What will be your answer?
2.72 ml.
2.72 ml.
ઓકે, સો હવે આપણે મોલારિટી આવી ગઈ. હવે બીજું શું ચેન્જ કરવાનું રહ્યું? જુઓ ઉપર શું લખેલું છે? યલો કલરથી હાઇલાઇટ કરેલું છે.
100 ml માટે છે.
Yes, this particular formula 2.722 ml H2SO4 is for 1000 ml. We have to prepare 100 ml. So for 1000 ml it is 2.722. For 100 ml it should be
0.272.
0.2722 ml. Right. So by this way you can prepare any sort of molarity. તમે કોઈ પણ જાતની molarity strength વાળું solution આમાંથી બનાવી શકો, provided you should know the molecular weight of that substance. So this is the secondary standard solution. Now what we need to find out its strength?
Primary standard solution.
Yes, so for that we have to prepare primary standard solution. So for this case we required sodium carbonate as a primary standard solution and we'll prepare 0.05 molar. એના જેટલી જ molarity strength વાળું બનાવશું. So here how will you proceed?
So here we convert it into mole. 1 mole, the mole of sodium carbonate is equal to, we need to convert it into grams.
Okay,
So we multiply mole into molecular mass.
fine. Can we use this જે red color થી highlight કરેલું જે statement છે 1000 ml H2SO4 1 molar is equal to molecular weight of H2SO4. So can we apply that equation over here? What I told you that whenever you want to prepare X molar solution, कोई भी molar solution તમારે બનાવવું હોય કોઈ भी substance નો, then in that case you have to weigh. First of all you need to find out the molecular weight. Okay, and when you have molecular weight with you, you have to dissolve that molecular weight into its 1000 ml. So for this 1000 ml 1 molar molecular weight of sodium carbonate is
106.
yes, it is 106 gram molecular weight of sodium carbonate. Okay, so for 1000 ml 1 molar solution you have to dissolve 106 gram of sodium carbonate into 1000 ml total volume of solution. Now what will be our next step?
To find for 0.05 molar.
Yes, so simple mathematics is involved. For 0.05 molar it is 0.53 gram. Now and directly I have converted into its 1000 ml में convert करने आप्યું છે મેં તમને, 100 ml માં. Okay, so the final gram of sodium carbonate you required for 100 ml 0.05 molar sodium carbonate solution, you require 0.53 gram of sodium carbonate, that is to be dissolved in 100 ml. So you will get 0.05 molar sodium carbonate solution. So our first part is over now. We need to prepare two solutions, primary solutions or primary standard solution and secondary standard solution. For primary standard solution, we prepared 0.05 molar sodium carbonate, and for secondary standard solution, we prepared 0.05 molar H2SO4 solution. Okay, so this is the preparation part. Now the standardization. So for standardization of sulfuric acid, we take sodium carbonate solution, our primary standard solution, in a conical flask. Its volume is 25 ml. So we'll take 25 ml of prepared primary standard solution, sodium carbonate. Into that, we'll add methyl red as an indicator, few drops of methyl red. Then to that resultant solution. So when you add methyl red, the color change will be like this. Yellow color जो तुमने देखा है because of methyl red. Then we need to titrate it against our prepared sulfuric acid solution કે એનું concentration આપણે શોધવાનું છે. So burette will fill prepared sulfuric acid solution and titrate drop by drop to conical flask containing sodium carbonate solution. So every drop of sulfuric acid will react with sodium carbonate. Sulfuric acid is acidic in nature, sodium carbonate is basic in nature. So every drop of sulfuric acid neutralize equal moles of sodium carbonate. જેમ જેમ આપણે સલ્ફ્યુરિક એસિડ નાખશું એટલે સોડિયમ કાર્બોનેટ એમાંથી ન્યુટ્રલાઇઝ થવાનું સ્ટાર્ટ થશે. Now at one point of time, what you find that is whatever 25 ml sodium carbonate you have, એ બધું જ ન્યુટ્રલાઇઝ થઈ જશે because of sulfuric acid. પણ એ તમને ખબર નહીં પડે. But because of presence of the indicator, જ્યારે સોડિયમ કાર્બોનેટ કોનિકલ ફ્લાસ્કમાં બચ્યું જ નહીં હોય ત્યારે શું થશે, જેવું બી તમે એક્સ્ટ્રા સલ્ફ્યુરિક એસિડ નાખશો એટલે એ અત્યાર સુધી તો સોડિયમ કાર્બોનેટ સાથે રિએક્ટ કરતો હતો, પણ સોડિયમ કાર્બોનેટ જો બધું જ ન્યુટ્રલાઇઝ થઈ ગયું હશે તો એ શું કરશે, મિથાઇલ રેડની સાથે જઈને રિએક્શન કરશે. મિથાઇલ રેડ ઇઝ વીક બેઝ ઇન નેચર, એટલે એની સાથે રિએક્શન કરશે અને એ જેવું રિએક્શન કરશે એટલે એ એનો કલર ચેન્જ કરશે. કોણ? મિથાઇલ રેડ. મિથાઇલ રેડની પાસે એવી નેચર છે કે એસિડિક સોલ્યુશનમાં અલગ કલર આવે અને બેઝિક સોલ્યુશનમાં અલગ કલર આવે. ઓકે, સો ઇનિશિયલી જે કોનિકલ ફ્લાસ્ક હતો એની અંદર બેઝિક સોલ્યુશન હતું એટલે એનો કલર યલો હતો. જેવું એ એસિડિક થવાનું સ્ટાર્ટ થશે, કેમ? બિકોઝ એમાં સલ્ફ્યુરિક એસિડ એક્સ્ટ્રા આવે છે એટલે શું થશે, જેમ જેમ
It changes to dark orange red.
yes, you will find the color change like this. Pink color માં change થશે. That is the property of methyl red. So in different strength, in different medium, it has got different color ability. So જેવું એ પિંક કલર આવે છે, યલોમાંથી પિંક કલર તમને આવશે, that shows the neutralization of sodium carbonate is over. That means no more sodium carbonate is present. So at that point of time, you have to find out the burette reading. So whatever burette reading તમને આ પોઈન્ટમાં મળશે, સપોઝ એ તમને 30 ml મળે છે, say for example. So what does it mean? કોઈ કહેશે મને? If the burette reading is 30 ml at this point of time, then what it shows?
30 ml sulfuric acid solution is needed to neutralize.
બરાબર છે, બરાબર છે.
To neutralize sodium
25 ml sodium carbonate solution. Yes. So by this particular titration, we need to find કેટલા ml ની જરૂર પડે છે for whatever ml we have taken for primary standard solution. So in this particular case, for neutralizing 25 ml sodium carbonate, we require 30 ml of sulfuric acid, say for example. Okay, now we need to do some calculation part. Yes, so for that we supposed to know the reaction between sodium carbonate and sulfuric acid. So based on that, you can say that, okay, what does it mean? આ reaction ઉપર તમને શું idea આવે between sodium carbonate and H2SO4?
Carbon dioxide is released.
Okay, carbon dioxide is released. Then
1 mole of sulfuric acid reacts with 1 mole of sodium carbonate.
yes, yes, that is our main focus on. We need to focus on the reaction between the molecular bases of the primary standard and secondary standard solution. So to neutralize 1 mole of sodium carbonate, we need to require, or we require 1 mole of H2SO4. Okay, so we have 1 mole of sodium carbonate equivalent to 1 mole of H2SO4 from this particular equation. Okay, so based on that we'll do the calculation, but before that we just recall what is molarity. So molarity is nothing but moles divided by liter of solution, or moles, number of moles in a liter of solution. Let us take molarity as capital M, mole as small n, and liter of that solution is capital V. And if we rearrange that the equation, then we આપણે શું કરીએ ખાલી લીટરને રાઈટ હેન્ડ સાઈડથી લેફ્ટ હેન્ડ સાઈડ લઈ જઈએ છીએ. So it is molarity into liter is equal to mole. That is nothing but small n is equal to capital M into capital V. Now based on this chemical reaction, if we write like this, 1 mole of sulfuric acid is required or is equal to 1 mole of sodium carbonate. Now moles ne આપણે n થી represent કરશું, n2, because n2 is 2 stands for the secondary standard solution, so it is n2. For primary standard it is n1. So ultimately it is n2 is equal to n1. કોઈને કઈ ડાઉટ છે અહીંયા સુધી? n2 is equal to n1 સુધી?
No, sir.
Okay, that seems to be fine. Okay, now based on that we need to find what is n2 and n1. So again recall the second line જે equation છે એમાં તમે જોઈ શકો કે mole n2 is equal to, or n is nothing but m into v. So if it is for n2 it is m2 into v2. એવું થઈ શકે?
Yes, sir.
And similarly for
Yes,
n1, for n1 it is m1 into, for n1
M1.
M1 V1.
M1 V1.
yes, m2 v2 is equal to m1 v1. Okay, now from this equation can we able to write down their values? Okay, what about m2? m2 ની value શું આવશે અહીંયા?
So we have to find
The molarity of sulfuric acid.
30.
Yeah, molarity of sulfuric
Yes.
acid, but that we don't know exact molarity, so that will be our question mark. What about v2?
Sir, 30.
ml.
Yeah, that is the
30
volume
ml.
of H2SO4, that is 30 ml. m1 m1
0.05.
0.05.
yeah, 1 stands for primary standard, so molarity of primary standard is 0.05, and v1 is
25.
25 ml.
25 ml.
25.
okay like this. So m1 is the molarity of sodium carbonate, that is 0.05 molar. v1 is the volume of sodium carbonate, that is 25 ml. m2 is the molarity of sulfuric acid, that we are going to find out from this equation, and v2 is the volume of sulfuric acid, that is nothing but the burette reading. So if you want to find out molarity of sulfuric acid in this particular case, then we have to perform the titration. Okay, so that's it for today's practical. So જ્યારે બી આપણને time મળશે, we'll do the titration, and we could be able to find out the molarity of sulfuric acid. હવે કોઈને કઈ ડાઉટ છે આમાં?
No, sir.
So
Sir, I have a
Sir,
doubt.
yes, please. Yes.